So it was very interesting this morning to listen to many people who did contribute a lot to the free software movement, to the open source movement. It's inspiring for me, and it's a good introduction, a good transition for me to explain to you what IRIL really is. So IRIL comes from French, so this means Initiative pour la recherche et l'innovation sur les logiciels libres. It is research and innovation on free software, but there is an extra leg to this. It is not just research, it is not just innovation, it is also education about free software, which are issues we actually have to study. Let me give you my point of view. I mean, free and open source software actually mean a radical change in society for many people. On one side, it is very important for us to have the possibility to build scientific and technological commons. This is what we are really doing by doing free software in general. It's an essential goal. It is also an essential goal because these scientific and technological commons are something which are shaping our life in the digital society, and having access to them means that citizens will get back control in a society which is taking control out of their hands. It's essential to have free software to get this goal. And this is something that probably is not stressed enough in all the kind of things we say, because we are very fanatic and passionate about technology, and maybe we forget about the implication it has on society. We should talk about this more. But if you want to focus on technology, it has been said many times already, free software and open source as a way of developing software, a way of collaborating, something which was not possible before the generalization of the internet, are actually completely changing the way of doing software, completely. I mean, you design software differently, you develop software differently, you market software differently, you maintain software differently. You educate people to use this kind of software different with open source and free software than with proprietary software. It is a complete change. And it's a change which is at the beginning, if you remember, 10 years or 15 years ago, everybody was saying, okay, this is so revolutionary, it will only work for infrastructures, okay, the network, the operating system. We will never see something like this in vertical markets like business intelligence or whatever. And now here we have it. We have free software projects everywhere. Okay, it's changing everything. It has an important impact in economy, in the industry, because even with all the pretty tilted and non-level playing field, as Ger said, actually free software has allowed to reopen competition in sector where everybody was believing in 20 years ago that there will not be any more competition. It reopens the door. It doesn't mean it put them wide open, but at least it's able to reopen. We are looking at software which is developing more efficiently, faster, cheaper. Okay, this is why there are so many companies jumping in to have this, of course. But also what you see, it's important, getting vendor independence is so new for IT users. I agree a lot with what you said, Ger. It's incredible. I mean, there are many things you learn about management. I should not say about this because I'm coming from a hard sciences side, okay? But when they say that people get stuck at the highest level of their incompetence, it is not so false after all. So you get very important IT decisions taken by people who do not understand technology at all. Okay?
It's not
so
specific to IT, that.
No, I know, but for IT it is more dangerous. You have network effects, it's terrible. So at least you should be, at this point, accept you don't understand anything about technology and you're making political decisions. So at least think about your political interests, and they don't do it. Well, anyway, so this is a context which actually important. But we are at a point where free and open source software is going to grow. It is growing already, and we are facing several challenges. One of the challenges is scientific, and we'll talk more about this. Well, actually, the speed, the size, the sheer size, the turnover of software in the free and open source software have gone to a point where I do believe that just working as a community without any new innovation, scientific innovation, is not sustainable anymore. Okay, we have to handle too many projects, too much lines of code. We need tools. We need science. We need research to accompany this kind of growth. We had another challenge, which is educational. How do we teach computer science. Actually, I was talking about the engineers here, but it's not just a matter of teaching computer science to engineers. It is a matter of teaching the basics of information technology and computer science to everybody. To quote again, Gare, when you say, I mean, with enough incompetence, corruption has a zero cost. Well, if you want corruption to not have a zero cost, you should reduce incompetence, making people more competent, telling people what's computer science, how to work all this from the beginning, and not just to engineers, but to everybody. And this is actually one challenge that is going to be taken over a bit by our community in computer science here in France in this moment, which is trying hard to have basic notion of computer science going down to high school and even lower, if possible. Having people the chance, giving everybody the chance to know what is this kind of technology which is going to change society. Not just a box you buy in the supermarket, okay? Understand what is going on. Understanding is fundamental. And so that's not the mission of IRIL to help teaching computer science in high school. Some of us are involved in doing this project outside, but I believe it is one of our mission to help teaching tomorrow's engineer how to work in a free and open source environment from the beginning. Okay, put them in contact with this right away. And again, help educating technical and non-technical newcomers to these false values and principles. This is really important to have a community grow, and having this community grow not just because you have people that believe you can get software for free, which is a motivation, but should not be the only one. And then you have another technology, another challenge, which is more economical. It's really a challenge to build an ecosystem where every actor finds its place. Okay, you have innovation and research which is done in academia. When you do research and innovation in academia, you could say, well, now to get value out of this, I get some software patents and try to sell it to somebody else who will buy it or something. That's a way. I do not believe this is the right way to build a viable ecosystem. Building a viable ecosystem is collaborating with other entities, which can be communities, can be companies around, and working around free and open source software is the right way to do this, but we do not have the magic recipe to do it properly every time. So doing experimentation is something we need to do. What I'm extremely happy is that I managed to see the three issues here written. Actually, they are written. If you take the time to go here in the INRIA's strategic plan for the next 4 years, this is actually written black on white. Right? It is part of the strategic plan of INRIA, and we are going to try to make this real. So when I was talking about scientific challenges, I do hear everybody this morning asking people at IRIL to come up with many statistical data about why open source software is important or is used, etc. Well, actually, I hope not to be, you will not get too much of a disillusion, but this is not actually the center of our focus here. We are going to work on something a bit different, which is to say, hey, look at the size of the components of the open source software component we have built collectively as a community. Okay, the Linux kernel is over 8 million. You see the speed. Now it is more than 8 million lines of code today, and growing. Look at the size of the Linux-based distribution you find around. I mean, these are data taken for Debian, which is, I believe, the largest distribution you have around, but it is quite similar to the figure you can see in Red Hat or other companies. There are over 20,000 components that evolve daily. They change and evolve completely. So actually, 20,000 is in the past. 25,000 was Lenny. I believe it is 27 or 28,000. The last Debian release, which was actually frozen yesterday, I do believe. Yes, but stabilized yesterday in a room next to this one. So it's huge. How do we go about maintaining quality of this kind of software, helping, by the way, companies that want to sell not licenses, but competencies, which is the right way to go this. So I do believe scientists have a lot of work to do to help the open source community maintaining this level of quality when we are scaling up and scale up, okay, to software sizes which are quite unbelievable. I mean, I would say this is completely unbelievable. If you think about something like this, 10 years ago, nobody would have believed would have seen something like this in open source environment. Another challenge in education, let me spend a little bit of time on this. Again, quoting David Patterson, who was president of the Association of Computing Machinery, he wrote in a very inspiring column in the March issue of the 2006 in Communication of the ACM, where he was saying, actually the title was not Join the Open Source Movement. The title was Computer Science Education for the 21st Century. And he was saying in a very illuminating way, well, we must stop teaching computer science the same way we were teaching it 20 years ago. Okay, many things have changed. 20 years ago, I was pretty happy to be writing code from scratch from myself. I had the chance to write for myself a complete assembler debugger for a little machine I had in 1982 or whatever. I understood everything. You could believe that you actually could have a global vision of computer science by just studying 4 years. Okay. Well, now we are in 2010. The situation is completely different. There are, again, we have seen millions of lines of code around, billions of lines of codes around, many projects, many communities. It is not believable that you can start from scratch and write everything by yourself. You must be able to collaborate, build on top of other components, and this is not easy to do. It is not easy to teach. It's not easy to learn. Okay. And what he said, you see, we should help people join the open source movement when they are studying in the university, not on their free time, which is what happens tonight. Join the open source movement not despite what we teach them, but in their work time, because we help them and we teach them the right way to do it. Maybe the right way, I don't know. We try to teach them and to help them doing this. That's a lot of work to do this. I can say it. I'm a computer science professor, not just researcher, so I know how hard it is to build a course. And so this means adapting curricula, building connection between communities, industry, and academy, because if I want to have students to participate in open source projects, I cannot just tell the students, okay, take whatever open source project you want, write to these people and join it. Come on. Okay. We need to help them connect with these communities and help them do this the right way, in an efficient way. We need infrastructure, we need textbooks. Do you have textbooks helping teachers who want to teach computer science in a new way with open source? If you know of a book, please tell me. Okay? I would love to buy a copy of it. As far as I did my research, I didn't find one. There are books about the movement of free software, about the business of free software, about the community of software, etc. But what about a book helping computer science teachers working about free software in a class? What are the exercises? What are the lessons? Where are the theorems? Where are the processes? Where is the meat I need to build a course? Okay. Well, all this needs work, and we will try to contribute to this at IRIL. So what we want to do at IRIL is to try to contribute to these three challenges: science, education, economy. Okay. And try to establish ourselves as this international center for development, research, and education on three axes. Again, safe and reliable free and open source software, and quality of the code, of the development of the processes. For the curricula, try to focalize here the efforts on building new computer science material, and also do experiments on technology transfer. Now, let me be a bit more precise. My goal here, our goal here, is not to just be a bunch of people staying here for 40 years and pretending that by being 20 people in this kind of nice premises, we know everything better than anybody else. That would be a completely wrong approach to the situation. What we are trying to